you can start.
Right now? Okay. So, hello everybody. Thank you for joining the webinar session on the HyBalance program. So I'm Guillaume Jorin, the program, the coordinator of the HyBalance program. So just to quickly introduce the program. So today we will discuss about the power to H2 topics. And we will have also a panel discussion on a question related to that. Just shortly, right now, I will give the floor to Mirela Atanasiou, who is the FCHU Head of Communication and Operation. And then afterwards, we will go more in details in the HyBalance program. So Mirela, if you want to take to welcome.
Thank you very much, Guillaume. Thank you very much for the nice introduction, and thank you very much for having the pleasure and inviting me today. It's really a real pleasure to be here with you today at this important moment of HyBalance project in particular, but important moment, I would say, for the entire hydrogen industry, or in particular for the electrolyzers technology. As you know, as a public-private partnership, the Fuel Cell and Hydrogen Joint Undertaking from the beginning has supported this type of activities, technology development, electrolyzers development as the only, in our opinion, as the only mean to produce, or the main mean to produce renewable hydrogen, of course, when electricity is coming from renewable sources, but also to exploit the possibility of the technology to offer services to the grid. And finally, why not to show the feasibility of electrolyzer technology in coupling or in integration different sectors of our economy, which I believe our project or your project HyBalance did, and you will show to us all later. The FCHU has not only supported electrolyzers and over the last 12 years supported almost 300 projects for more than €1 billion funding, public support, not only in hydrogen production technology, mainly electrolyzers, where we supported a lot of projects for more than 100 million so far, but also supporting fuel cell development for different applications from the transport side, but also for the energy side, lately moving into the transport side, into heavy duty application, which we all know they are very hard to decarbonize. And probably the electrification will not be the only solution, and hydrogen is showing there being the main solution. As of 2014, you know, efforts were more and more focused on moving in the electrolyzer to the megawatt scale. And HyBalance, for us, and I believe for everybody, is the first example to prove and validate the technology at this scale, at megawatts in the field. And we are very happy to see today its complete execution, that it's coming to an end and it's showing really good results. You also may know that in the last years, we have increased our efforts on the electrolyzer side, and now we are supporting different technologies of different companies at 10 or 20 megawatt scale. And you probably may have learned recently, European Commission published the 100 megawatt call. So we are really pushing from the technology side to move to this larger scale in different environments, of course, for providing hydrogen for different sectors, or using in different sectors. One more thing I wanted to also say today is that with all these efforts over the last, I would say 12 years, but the electrolyzers efforts are mainly for the last 5 or 6 years, we are very proud in Europe that we have secured leadership worldwide. The electrolyzer technology is here in Europe, and I hope we can consolidate this leadership, and we can build or continue to build the supply chain and even the value chain in Europe. I will not take more time, and I would like just to finish by congratulating the whole consortium for doing this. In particular, Air Liquide for coordinating this project, promoting this project, being the project promoter, but also the electrolyzer manufacturer, Hydrogenics. I still like to call it Hydrogenic. I know now it's Cummins. And I would like to congratulate both of you, because without you, the project will not happen. You believed in it, you made it, and really congratulations from my side. And thank you very much for doing that. I trust we will continue doing that, all of us, all these efforts. And why not in the few years, in a very ambitious plan, according to the European Hydrogen Strategy launched in 8th of July, we will be able to move at gigawatt scale when we talk about electrolyzers. So really, thank you very much for the invitation. Thank you very much to the consortium for making this happening. Very proud of you. You will remain for us the first project to be proud of moving at megawatt scale. And I hope we will have very good discussions. And again, I'm here for any questions you may have. Thank you very much.
Thank you very much, Mirella. I think we will have an interesting discussion after that. And just to quickly share the agenda of the webinar. So I will just to have an overview of the discussion of today or this morning. So mainly the topic today is the power to hydrogen. With the example and indeed with this first major key, which is the major milestone, that is the HyBalance project. So I will shortly give an introduction of the project, and then we will have the different partners. So as explained from technical performance of the electrolysis technology from Hydrogenics. We will have also a global overview of the plant operation and the economics by Diederik Lusten from Air Liquide. Also, one of the important topic is the grid balancing services. So this will be presented by Lotte Rasmussen from Centrica. And then we will have an overview of the environmental performance regarding the greenhouse gases emission of the process by Patrick Schmidt from LBST. And then we will, so this will be it's a straight presentation, and then we will open the floor for a question from the chat channel. And it will be moderated by Thijs Losten Jensen from Hydrogen Denmark. And then we will have a next session with open discussion with on about two questions regarding the role of electrolyzers in the grid balancing and importance to sustain the more share of renewable energy, and what is the future of the market development and the EU regulatory frameworks. So for that, we will have a panel discussion with the former participant partners, and where we will add Gregor Pavlek from Hydrogen Europe and Daniel Freile from Wind Europe. And this will be also moderated by Tess Losten Jensen. And then also a special thanks to Nikos Limperopoulos from the Fuel Cell Hydrogen Joint Undertaking, who is the program project officer of the HyBalance program. So we will sum up and conclude on the webinar. So just shortly, I will start with the introduction. And just so power to hydrogen is the rising topic, and today it's very important on the place. And just to come to the origin of the HyBalance program, So just to remind that hydrogen is a vector of energy, of the energy transition. And so it enables to sustain the wind power and the intermittent renewable energy by storing the hydrogen and using that in several applications. So why we choose Denmark? So we have to go back in 2017 and 15, sorry. So Denmark was selected because it has a high potential and very strong involvement in increasing the share of renewable energy, especially from wind power. So, and the market also was there with several hydrogen refueling stations, so to serve mobility. And also there are customers for industrial customers for using hydrogen. And especially with the site selected was Hobro in the north of Denmark in the hydrogen valley. So then if we look at the project more in details, so the idea of the HyBalance project is to demonstrate the overall chain of power to hydrogen, in fact. So from the production of electricity from water electrolysis, so basically using the wind energy from the grid, and this making a low carbon hydrogen. So then it's also include the storage of the hydrogen. So which actually act as a buffer, in fact. So the idea is to produce the hydrogen when there are a lot of wind energy in the electricity grid. So that we can store this excess of an electricity energy into hydrogen, and then later supply that to several customers. So as explained, for the mobility market and also to industrial market. So another point very important on this project is to also demonstrate the maturity of the PEM technology. So this is a very important step because it's a first of its kind plant in operation, in real operation under industrial condition. And this technology is very interesting to provide grid services, and especially on the primary markets, and also to regulate the secondary and tertiary frequency markets. So this is to have a global overview of the program. So and to explain the principle of the power to hydrogen. So then if we look at the figures of the program, so it started in October 2015, and it will end at the end of the month. So we are almost completed on the program, but it doesn't mean the HyBalance plant will not continue to produce hydrogen, and there is a lot of hours behind to where the HyBalance plant will perform. So to give an overview of the project budget, so this is a 15 million euros project with a very important contribution from the fuel cell hydrogen joint undertaking, almost more than half of the budget, which is a very, so we can thank them for that. And another important contribution is from the Danish organism, the Danish authorities, EUDP, at a level of 2.6 million euros. So just to give an overview also about the partners. So as explained, we have Air Liquide, who is in charge of the project management and the construction and operation of the plant. There is also LBST, who is in charge of the environmental assessment and coordination of this task. We have Hydrogenics and now Cummins, who have manufactured the electrolyzer and install it also on the plant and doing also some maintenance on that. Hydrogen Valley, who is the communication partners and make this webinar possible. So thank you to Hydrogen Valley for that. And Neas Energy, now who became Centrica, in charge of with the balance responsible parties. In fact, they are working on electricity trading and providing the hardware to perform grid balancing. Also, an overview of the plant to understand the whole scope of the production and the delivery. So, as I explained, it's regarding the boundaries, we are starting from the connection to the grid, where we have the power transformer and harmonic filters to stabilize the power inputs. We will then go to the electrolyzer, where from water electrolysis, we will produce low carbon hydrogen. And then we have also the compression units to enable storage at under pressure of the hydrogen, and to be able to buffer the production and then the deliveries. And also what we need to consider is the trailer filling station. So there are two modes to distribute the hydrogen. There is either truck trailers who are delivering all around Denmark the hydrogen to customers, industrial and mobility. And the plant is also equipped with a pipeline who can supply directly close industrial customer, so which is alimented on a regular, on daily basis. So one of the most important challenge of the project is to perform also to produce hydrogen, but also to make all this equipment work together in automated mode, and which is very challenging in industrial condition. So by now there have been a lot of testing of in laboratories and let's say defined conditions of the PEM technology. But really the challenge of this project is to have a full industrial working in principle. So this is for the introduction of the HyBalance program. I will give the floor to Thijs Losten Peterson to present the session 1 and the different to introduce the different partners.
Well, thank you very much for that, and thank you for the presentation and the introduction to the program. It was very both informative and thoughtful. Yes, thank you also to the whole consortium for inviting me to moderate today's webinar. My name is, as Gilles mentioned, Thijs Larsen Jensen. I'm the CEO of Hydrogen Denmark, the national Danish hydrogen and Power to X organization. And in that capacity, I also want to express my admiration for the partners for making the project come true. But also, actually, I have the pleasure also to be a board member for on the board of the EUDP, and as Guillaume mentioned, we have contributed also to the funding of the program. So also in that capacity, I would like to say that it's very nice to see that the project has moved along so well. So with the without but again, it's not my my point here to say too much. It's my point to moderate what everybody else is saying and telling us about the project. So without further ado, I think we'll move on to our next speaker, the first speaker in session 1, which is Dennis Thomas from Cummins, and as Mirella already explained, Cummins used to be hydrogenics. I think a name that at least some of us still has a more familiar ring to, but we will adapt to the changing times. So anyway, but Dennis, happy that you could join us today, and please, you have the floor.
Okay, good morning to all of you. I hope you can hear me well and see the presentation. My name is Dennis Thomas from Cummins Hydrogenics. I'm in charge of the global business development for the electrolyzer business. And obviously the aim of this presentation is to make a deep dive on the megawatt scale PEM electrolysis, which has been deployed for the HyBalance project, and also to discuss the lessons learned and the way forward. Yep. A few words of introduction about who is Cummins, because you might not be familiar with this company. So Cummins, in fact, is it's a US company with more than 1 years of history, mainly in the field of combustion engines, both engines for like the mobility sector, especially in the heavy duty trucks, buses, maritime application, trains, etc. But also for power generators, so gensets, either diesel or gas. And obviously, because of the energy transition, Cummins has decided to invest massively into new low carbon technologies. And in 2018, they've made several acquisitions in the field of electrification, mainly in the field of batteries. And in 2019, they've made several acquisitions in the field of hydrogen and fuel cell. Cummins is a true global company with a presence in more than 190 countries, more than 60,000 employees. The company owns its own distributor and dealer locations with more than 8,000 locations, and is investing also quite massively in research and development. To give an idea about our presence in Europe, with more than 7,000 employees, 11 manufacturing sites and distribution sites. And so to summarize a little bit the activities of Cummins in the field of hydrogen, we are working on several of them, both on alkaline and PEM electrolysis, but also on solid oxide and PEM fuel cells, and recently also on hydrogen storage tanks. This is mainly due to the acquisitions and some partnerships with General Electric on the solid oxide fuel cells, the acquisition of Hydrogenics, which was the most important one for the electrolysis and the PEM fuel cell part. There's also a partnership and a participation with Loop Energy in Canada, and a joint venture with Nprox in Germany for the hydrogen storage tanks. And the idea is to be able to provide a complete hydrogen solution for both the mobility sector and for the hydrogen generation. In Europe, we have two main manufacturing sites, one in Belgium, where the electrolyzer system has been built for the HyBalance project. We have also another site in Germany busy with fuel cell integration, and for instance, for the integration of the fuel cell in the hydrogen train of Alstom. HyBalance was a PEM project, so a PEM water electrolysis project, and the timing of HyBalance was fitting perfectly our technology roadmap at the time at Hydrogenics, because we started to work on PEM already in the late years of the previous century, doing some R&D, especially from the PEM fuel cell team. We had a small product already in 2003, but very small scale. And that's really in 2012 when we saw the first sign of the real energy transition that we decided to invest into the PEM technology, especially for the megawatt scale capability. In 2014, we manufactured our first 1.5 megawatt cell stack, which was installed in a project in Germany, a first project that was our real first megawatt. But the real interest of the HyBalance project, which was in fact decided in 2015, was to be able to test a dual cell stack, so 2 cell stacks in the same system. And obviously, after the HyBalance project, there have been some additional developments that will be presented at the end of the presentation. So just to give you a view of the core of the technology which has been deployed in the HyBalance project. So it is based on a PEM cell stack. In this case, this is a 1,500 square centimeter PEM cell stacks. The cells are placed horizontally, and the maximum capacity of this type of stack is 250 noble cubic meter of hydrogen per hour, which is equivalent to more or less 1.25 megawatts in nominal capacity, and it has the possibility to be operated a bit in overdrive mode. This view of the HyBalance project has been already presented by Air Liquide, but you see the electrolyzer, which is located on the top right of the picture. If we have a look a little bit deeper into the technology, you see that it is made out of 2 containers. One container, a 40-foot container, is in fact including the power rectifiers, as well as the stacks and what we call the balance of stack or balance of plant. And then there is a second container with all the utilities, so meaning the reverse osmosis system, the control panel. There is a big rooftop cooler and also an air compressor in the system. You see here a view of the unit before delivering it to Denmark. So it was still in our factory in Belgium at that stage. And you see here the system deployed on site in Hobro in the center of Denmark. Here is a view of the inside of the electrolyzer, where you can see the 2 stacks, 2 PEM stacks, which are connected on the right side and then connected to the rest of the plant. What are the lessons learned from this project? For us, it was the first of its kind, where we were in fact using 2 PEM cell stacks running in parallel and sharing the same balance of stack. So we have made a lot of hardware and software improvements on this project. It was a real pilot project, so we had a lot of troubleshootings to be done, and actually that's the aim also of those projects, to test new things, and that's why the FCAGU is financing and helping those developments, and EUPD as well. We tested quite well also the dynamic response of the electrolyzer, and it was validated during the testing phase. We have learned a lot on the dual stack operation and also on the maintenance of the system. And considering the pilot nature of the project, we have achieved a very reliable operation. On the manufacturing side, we have also made some improvements in the way we were manufacturing those type of units. So working in a clean room environment for the assembly of the balance of stack. And we have also developed in-house testing protocols, especially for the factory acceptance test, considering the new nature of this project. Concerning the installation and the operation of the electrolyzer, the installation, I would say the unloading was done in 1 day. I encourage you to have a look at the video, which is present on the HyBalance project website, where you will see it and also a lot of pictures on the project. Concerning the some of the lessons learned, what we can tell about PEM technology is that water quality is one of the most critical elements when we want to operate a PEM electrolyzer. It is crucial to prevent any contamination of the water, which would in fact contaminate the stacks. And I can tell that we have had some issues on this project. And so we had in fact to also develop a procedure to exchange the stacks on the HyBalance unit. And this is one of the main learning that we have made on this project. And we've made quite a lot of improvements actually on the water controlling elements. So filters, reverse osmosis maintenance, but also a lot of improvements in a water polishing system, which is all the time controlling the water quality in the system. Also, we have developed annual testing procedures to make sure that we could control the main parameters of this type of units, and obviously a lot of experience to develop further this product. Concerning the main numbers of this project, we have produced more than 120 tons of hydrogen, and those have been delivered to the end customer. In terms of operating hours, we are close to 14,000 operating hours. That unit was operated quite continuously over the last 2-3 years, delivering also grid balancing services. Concerning the system efficiency, including also all the utilities that I have presented. So it means that we monitor all the electrical consumption of the 2 containers that have been presented. We have achieved an efficiency of 56.5 kilowatt-hour per kilogram of hydrogen produced, while the target from the FCEG call was set as at 57.5. So this is, I would say, succeed in this respect. On the cell stack, we managed to operate them asymmetrical. So we could operate on one stack or on the 2 or a different power on the different stacks. So that was an important learning also from us. And in terms of reaction time, in real operation, we could deliver services in less than 10 seconds. But in fact, the system is able to react quicker than those 10 seconds. In hot state, we can go to any power set point in less than 2 seconds. Obviously, the HyBalance project has been a very important project for us. That's on this project that we have developed the dual stack platform, which we call today the HyLyzer 500. And this HyLyzer, this HyBalance project, in fact, has allowed us to develop a number of additional projects. You see them there on the list. And one of them is the Aeolus project, which is also a project funded by the FCGU, which is today in the installation phase. And you see that we are not stopping there. We are also developing at the same time HyLyzer 1000 platform, and that will be the main part of the last part of this discussion. So what is happening after HyBalance is that we are currently upscaling our PEM cell stack by doubling the amount of cell, because the cell stack which was used for HyBalance is presented on the right side, and we are developing the cell stack which is presented on the left side. So to achieve hydrogen production capacity of 500 normal cubic meter of hydrogen per hour. Good to mention is that the operating pressure, the design pressure is 30 bar of the system, which is quite advantageous. And this upscaling of the stack is also organized together with a new product development on our side, which is called the HyLyzer 1000. That's the unit that you see here on the left, which is in fact containing the 2 cell stacks of 2.5 megawatt each, on which we have developed what we call the balance of stack, which is containing all the water equipment, the cooling of the system, all the safety instrumentation, etc. And we are building today a 20 megawatt project together with Air Liquide in Canada for an industrial customer. This plant, which is containing 4 HyLyzer 1000. So for a total capacity of 20 megawatt, each of them connected to a single rectifier. And then all the balance of plant is organized by Air Liquide, where you see a central cooling system, a central hydrogen purification system, a central water purification system, and also a central medium voltage system. And this unit should be operational by the end of this year. We are today busy with the commissioning. I'll not spend too much time on this, but here is a summary of all the products of Cummins today concerning the electrolyzer. And the HyBalance has really allowed us to develop this HyLyzer 500 platform, which is a containerized system, and everything which I presented for the HyLyzer 1000, these are indoor units. So what are the conclusions from our side? Obviously, we have made a lot of learnings, and we managed to convert them into a commercial product, which is today available and deployed on several sites. The good news also for everyone in the project is that the HyBalance unit will continue its operation after the end of the funding period. So it means that the system is operating under economical conditions. As I've presented, we are building now the 20 megawatts. So we are in fact getting prepared for the gigawatt era of hydrogen technologies. And we want to say a big thank you to all the HyBalance project partners, which have allowed this project to be a real success, but also a big thank you to the funding authorities, the FCGU, and the Danish EUPD program. Thank you very much for your attention.
Well, thank you very much for this very interesting presentation. I think we got, at least I did, a very good understanding of how the project worked, but also how it works, but also how it will be able to. I had been able to help in the developing of the electrolyzer technology. That was very interesting. Thank you very much. As I know there's quite a lot of questions in coming in, but as I mentioned originally, we will sort of collect the questions and do them in one session altogether when we finish the initial presentations. So it's my pleasure to introduce the next speaker, Mr. Dietrich Lüten from Air Liquide, and please, you have the floor.
I hope you can all see my screen. Can you see my screen, Tesh?
Well, I can at least, so I hope the rest of the can as well.
Good. Thank you very much for having the opportunity to be in this session. My name is Ludwig Lüten. I'm in charge of the let's say the hydrogen energy market in the what we call the NEC cluster in the Air Liquide set of clusters, meaning that it is Northwest Europe, Scandinavian countries, and Russia, Kazakhstan. So we cover quite a large geography. We have had the big pleasure and also the big learnings from operating this plant. And what I would like to do with you is guide you through some lessons learned and how we realized the project from an operations perspective. So there's, let's say, first of all, the Air Liquide Group is very active already for a long time in hydrogen. We have more than 40 years of market experience in developing the hydrogen market, and use different technologies, in fact, to produce those hydrogen. The first one, in fact, there are two big groups in, let's say, production that we operate today. One is on the what we call methane steam reforming, which is natural gas, as you see here it's the carbon, and we do some carbon capture in the future. So it's still, let's say, a conventional production of hydrogen. It's a cheap production of hydrogen, emitting CO2, but we are embarked into several large projects to capture CO2 with very big leading projects today in Rotterdam and in Antwerp. But also in France, we have what we call the CryoCap. It's a different technology, so we test all those technologies to capture CO2 and to sequestrate that in all the oil or gas fields. The tendency, however, is to get more and more into renewable energies to produce hydrogen. So we do that through electrolyzers, which is one of the big lessons learned and what we captured from this project. As we also need to master more and more the technology to progressively inject more and keep up with the growth, to have additionality, let's say, of renewables into the networks and into our customer base. And the third method of, let's say, producing carbon neutral hydrogen is by using biomethane. We in fact separate biomass after digesting it into CO2, and we, with membrane technologies, we take the biomethane out. We can have as a feedstock in our classical steam reformers, which is then also greenifying, let's say, the current way of doing it. And then last but not least, there's some streams in the industry already where there's hydrogen available as a byproduct, getting into byproduct, for example, for the chloralkali processes, where we capture this, purify, and use it in our networks and distribute that into the market. So there's a large need, let's say, in the future for low carbon hydrogen, because we all would like to decarbonize this world, and we distribute that within Air Liquide to let's say existing markets, but also a lot of new growth and opportunity markets. The existing markets, it's more about the steel refinery markets. We are in the glass markets for doing glass polishing, but also in the electronic sector, where we're in at the high end of the market. We produce or help our customers to produce wafers for chip production that are used in your telephones or televisions and so on. And then there's the new growth opportunities that are coming up, which is more about the industry, where the industry would like to decarbonize themselves and where there's a new energy factor being needed. We are developing the hydrogen mobility market, especially focusing on the big consumers in this market, like the heavy duty vehicles, shipping industry, in the future, the airplane industry. So a variety, let's say, of industries where we'd like to replace combustion engines as much as possible by fuel cell technology, or use hydrogen in combustion engines directly, which is also feasible. And then the last but not least is the production of synthetic fuels, so more the power to X market that also Tesh mentioned, which is an important market. Apart from that, there's a lot of conversion needed for natural gas, let's say, in the pipelines of many gas and infrastructure operators, where hydrogen needs to be injected more massively and generated by renewables. So focusing on the plant in Hopewell itself, where we're very proud to have realized this project. We're selling basically the hydrogen produced either through tube trailers that you see on the front of the picture into the market, distributing that to the customer base that I just explained. And there's also let's say, connected to this plant, there's also a partner customer that is using the hydrogen through the pipeline network directly. So it's a base load on the plant that we use, and let's say we buffer as much as possible as we can, catching up for all the fluctuations of consumption in the pipeline network. This plant is unique in the sense that compared to some other techniques, it delivers a very high quality product of hydrogen that is directly suitable for fuel cell consumption, as fuel cells are pretty sensitive to certain pollutants in gas, so not all the methodologies are usable directly into fuel cell technology without purification. So this plant does, which is one of the big lessons learned, and also one of the upsides. And so what we serve generally is let's say the market is the glass fiber. We are in the oil and gas market in Denmark, steel manufacturers, and there's a lot of opportunities also to develop in the Hydrogen Valley, where we are proudly part of in the Hobro area, where there's some new needs coming up, like large-scale fuel cell testing for one of our important customers. There's some power-to-X projects that would like to be tested small scale in laboratory phases and so on, that we can get around the plant. But also the university or some food markets are very interested in joining up and seeing how we can explore the site together and optimize the consumption. We have still some product available. To get to the engineering, procurement, and construction phase of the plant, to give you some background information, we have 40 orders of equipment being sent out, so this is still very reasonable. We had very good subcontractors helping us there, already aggregating some of the techno bricks and doing that for us. There's a lot of concrete into this site, 230 cubic meters, and a lot of steel also to reinforce that. 69 tons, and you know, only let's say the civil works already required roughly 4,500 man hours. And this is very important because of the stability of the underground that we need to realize, because of the compression part and the vibration of compressors that are large compressors, in fact, to bring up the let's say the pressure up to 700 bar at this location. So we do different stages, and we can buffer up to more than 900 bars at the station. Then there's the mechanical erection. It's 400 meters of pipe, 3,000 man hours, and the electrical and instrumentation part, where there's 18 kilometers of cable into the site, and 5 tons of material, and also more than 4,000 man hours. So this is, let's say, the hydrogen piping also that we have used at this location is up to 1,000 bars, as we are compressing, let's say, an operating pressure above the 900, and of course 1,000 bars is up to the working pressure of those pipelines. I think the bursting pressure is much higher. So we have done in the first let's say the first semester of 2018 a lot of tests. We got the approval process for the quality, of course, of the product, where we would like to use that in the mobility market, which is very sensitive, as I said. There's the design adaptations. Not everything went well in one shot, but almost. We have been very keen on making some design, let's say, modifications already during the erection and startup process, and we realized the connection to the pipeline. And then we had the gradual ramp up. So it's more about reliability improvements. We have been testing very new spot-on technologies within this plant, meaning that, of course, when it's the first of its kind, you run into things that you have never thought of. So reliability has been an issue in the beginning, but we get it more and more under control. And as the partners of Hydrogenics also told, you know, we get it more and more under control, and it's quite a stable operation today. So operationally also we have it done. So we have 120 tons, as mentioned, being produced, and more than 200 trailers being filled. Taking into account, of course, that we did a lot of testing and let's say operations challenges at the location, because it's also a research project and dissemination to be done like today. So some operational results. We have 14,000 hours of operation. You see the curve where there's some, let's say, some spots where we were a little bit weaker in production because of some repairs, some modifications to be done to optimize the plant for the future. Overall, it has been operated with very good results on the technical performance. Also, the PEM technology was a good technology that we integrated here, thanks to Hydrogenics and Cummins. So we have, in terms of plant certification system, we've been very active on the frequency containment reserve, meaning that we have the grid balancing, where we can, as it was shown, react very quickly between 10 or 2 seconds to regulate the frequency, or to help to regulate the frequency for the grid operator. Of course, safety and regulation was a point in the installation, so to install it, but also to get all the procedures in place, having the firemen and everyone around the site being trained and also understanding what we do. So this went all successful, and we are delivering now our customers 24/7 without interruption, which is very nice result, I think, of all the teams that work together. Some economic results, we make that relative to each other, but here you can see the cost stack of what we have realized within the project, as it is still a relatively smaller scale project of a 1.2 megawatt electrolyzer. there's a capex part which is almost identical to the let's say in our P&Ls on the OPEX part, but also on the electricity costs. So it is quite in balance for the three blocks. If we go to larger scale electrolyzers like we are installing today in Canada, you see that we already make a significant step into the future, where the electricity costs become more dominant than the operational and capex part. And even when we go further, and this is on our roadmaps for larger scale production of 100 megawatt, we see that the energy cost is playing a dominant factor, meaning that the grid balancing and everything we do and the lessons learned that we have from this location is absolutely very, very fruitful to optimize the cost of the intake of energy, which needs to offset, let's say, the capex and opex cost on a location like this. One of the lessons learned also is that the auxiliary, so everything that we consume in terms of energy or cost around the plant itself is significantly ramping down the more we get into a scale-up, and it goes from water treatment to computer systems. Let's say everything that we have around the plant is important to get optimized, including the compression capacities. So the more we have scale-up, the better we will become in terms of competitiveness. So where do we stand today from our perspective? We have let's say we started with 30 electrolyzers worldwide in operation within the group, with a range of 50 to 100 cubic meters an hour. We're now at the 250 cubic meters an hour in the Hopewell plant. The next one is under construction. Let's say is commissioned as we speak. It's the Bécancour plant in Canada, which for us is a big step up. It's the largest today under construction in the world. And then the next phase where we are working on is to get to a 200 megawatt scale. So we're actively developing this kind of projects from a group perspective together with all our partners. So a lot of lessons learned and a lot of let's say things that we integrate already into our new plant operations. So thank you very much for your attention. I would like also to thank all the funding partners and the partners in operation that have made this project to a success where we stand today. And we're looking forward to answer all your questions and your questions later on in the program. Thank you very much, and I hand over to Tesh.
Well, thank you very much again for a very interesting and thorough presentation. I think it was a pleasure also to see the connection between the HyBalance project and the huge ambitions and progress that Air Liquide is making around the globe with regard to hydrogen and electrolyzers. That's really fascinating, and I think also an illustration on the speed and the momentum of the hydrogen industry at the moment. So, but moving on, we will also hear about the supply of energy to the electrolyzers, etc. And to tell us more about that is Ms. Lotte Holmberg Rasmussen from Centrica. So, Lotte, please, you have the floor.
Thank you very much. I just need to make sure that you can see my screen. Here it is. Yes. Thank you for the introduction. I'm from Centrica Energy Trading in Aalborg, which is quite close to Hobro. We are a part of Centrica. And I will tell you about our role and the balance responsibility and grid balancing in the HyBalance project. So first of all, a little bit about how is power to X, or production of hydrogen, seen from the electricity system, namely as a flexible electricity consumption. And so that's sort of the one important part. The other one is converting, of course, the electricity to some kind of fuel, hydrogen and other e-fuels. And the important part is to use electricity when the prices of electricity are low, in the spot market that you can plan the day before, but also to use electricity for balancing the electricity grid in the hour and the day of operation, sometimes called ancillary services or system services. So the grid balancing is done by the electricity markets. And that's why there's a need for a BRP. I'll tell you a little bit more about that. There's of course also a need for every other, all kinds of other participants, but the BRP is important. So what is a BRP? That's a balanced responsible party. And this slide shows you a little bit about how it all works with electricity markets. So the BRP has the sort of communication to the producers and the flexible consumers, and start and stop those units in all the different electricity markets. So the producers and the consumers will bid into the markets through the balanced responsible party, and these bids will be sent on to the Nord Pool, which is a spot market and other markets, and to the TSO, which are handling the balance in the operation day and in the day of and in the hour of operation. A little bit about what is Centrica Energy Trading. As I said, we are part of UK-based Centrica. The Centrica Energy Trading is the name of the sort of the Danish part of Centrica. And we have two main business areas, trading electricity and gas and certificates all across Europe, and being a balanced responsible party for some physical assets. And on the map, you can see the total that with the BRP for. It's a total of 14 gigawatt or 14,000 megawatts. And many of those, or some of those, are CHP plants. We have approximately 200 CHP plants as our customers in all sizes from 1 to 400 megawatt. So we have done optimizing and advising for many years. There's also coming more and more flexible consumption into our portfolio at our customers. Electric boilers were some of the first. Heat pumps are really starting to pick up now. Also, we have some EVs, and of course now also electrolyzers, HyBalance and another plant also. And we expect there to be a lot more of those in the future. Then we also bid in for renewables and utility and supply companies. Okay, so a little on our role has been, we made a business case and we have modeled the plant in all the relevant electricity markets. I was looking at those reports, and it's a 5-year project. Those were done some years ago. And what I will say is that it's interesting how markets change. And this is something also you have to note, that electricity markets change, not the rules change, not so fast, but also the prices in all the different markets change. So what was a good business for flexibility 3 years ago, one market could now be another market where all the values are. So that changed during the times. We have helped set up a remote control box at the plant so that we can send a signal to the plant, the HyBalance plant, if any if bits in the different electricity markets has been won, and the plant has to start and stop in the different markets. Air Liquide can access our signal and then start and stop the plant. And the plant has been tested by the TSO in all the different electricity markets, and it performs very well. Then the other thing that we are also supplying in this project is we have a bidding platform that is called NEAS Direct, and it is accessed through the internet. So that's the tool that the HyBalance plant, but also all cogeneration plants, flexible consumers, they bid in through this platform, or we can do it for them. Bids in the spot market are made the day before the operation, according for the HyBalance how much hydrogen is needed for the following day, and of which prices are the lowest for the following day, where the plant will make a profit on hydrogen production. Bidding in the other markets and regulating in the other markets follows the bidding in the spot market. And you can, I mean, if the plant is running, then you can deliver up regulation in different markets. You can shut down the plant, or if the plant is not in operation, you can start it up and deliver down regulation. Our role has also been to support with the optimal trading strategy for bidding in different markets and looking at which are the which are most value in. Yes. Okay. A little more on the electricity markets. The electrolyzer at the HyBalance plant, and also other electrolyzers, of course, but it can participate in all possible markets. DK1 is the price area where the HyBalance is, and there's different markets, and I'll just mention them shortly so that you know what I'm talking about. There's a spot market, done bidding the day before. There's the intraday market where you can bid up to 1 hour before. Then there's some ancillary services, manual reserves, regulating power market. A form of regulating power market is the special regulation. And these days there's a lot of money in this market. And then there's also the frequency reserves. And as I mentioned before, these markets change. So actually it looked 3-4 years ago when the plant was built, like there was a lot of value in the frequency market, the frequency reserves, but actually now the value is more in the regulating power market and the special regulation power market. Okay, so you bid the plant will bid in through our platform, and we'll send a sort of a signal back if we have won, if you have won or not in the different markets. And we will, our operation officer will keep an eye on the plant if it's running according to the bids. Here's a little figure on, it's just an example of the NEAS Direct platform where you can give in bids, but we also can follow how the plant is running right now. So this, what you can see is that it started as its consumption is minus. So it started running 1.2 approximately is this megawatt, and then up to half load, and then again down to full load, and then about, what was it, 11:30 something happened, so it had a slight stop. And so we can keep an eye on that and see if it's doing well in all the different markets. Okay, this is a second last slide. The conclusion from our side is the electrolyzers for Power-to-X can participate in all the different electricity markets, day ahead, intraday, auxiliary services. For an operation strategy, the most important thing is to bid in all the different markets in order to catch the best prices. The prices vary during the day, and you know the spot prices the day before, but in all the other markets you don't, for example, in the regulating power market, you don't know what prices will be in the next hours. You need to bid in, and sometimes there's really a lot of earnings to be done. If, I don't know, the wind is catching up or something, then there can be a lot of need for consumption, for example. Okay, so participating in all these markets can really increase the value of flexibility of an electrolyzer. And of course, you need to set up a plan. You need to set up which prices will this plant fit in with. Every plant is unique. You need to make an operation strategy based on the data for the plant and all the constraints like storage or whatever it could be. There's also some other things to note. It's actually possible to participate in different markets, maybe with half the load one and half the load the other market. And also these days, the variable tariffs, so the DSO tariffs, they are in some parts of Denmark and maybe also in other countries. They vary from, for example, in the winter, at night, there can be very high tariffs. So it's also important to take that into consideration so that you don't run the plant in those specific hours. Okay, the last slide is sort of the key takeaways. It's important to see production of green hydrogen as a flexible energy consumption that can take off the variable green electricity consumption and balance the grid. There is a large economic value in participating in different markets and being flexible with the electrolyzer. And it's important to do bidding in all the relevant markets in order to catch those that really can contribute to the business case of green hydrogen. Thank you very much.
Well, thank you, Lotte, for also once again another very interesting presentation, also showcasing perhaps some of the more hidden but very important aspects of a project like this, how to integrate with the energy system and make that that connection. I think that was very interesting. We're running a little bit late of time, so no further comments from my side right now. But moving on to our next speaker, the last one in this session, Mr. Patrick Schmidt of Ludwig-Bölkow-Systemtechnik, which will tell us a little bit about the environment and performance of the plant. So, Mr. Schmidt, please, you have the floor.
Yeah, thank you, Thijs. Thank you all the preceding speakers. And I think that very well fits into to make the picture round and sound about HyBalance. I will give a glimpse into environmental performance of the HyBalance project with the next few slides that we have. As mentioned, LWC had actually two roles in this project. The first one was proposal coordination. So before the project actually started, we were successfully getting the consortium together and getting it through the proposal procedures. And now in the operational phase of HyBalance, we have been doing an environmental analysis of the HyBalance plant and all its implications regarding greenhouse gas balance. And that's what the focus will be in the next few slides. It's always important to understand the boundary of a greenhouse gas balance, so the life cycle assessment system boundary. We have two cases here with the HyBalance plant, as have been mentioned by Guillaume and the others. There is, for the one side, trailer filling, the two trailer filling sites in the HyBalance plant, and there is this pipeline supply to industry. So both have been covered with our greenhouse gas balances, which go all the way upstream from the HyBalance plant, including the renewable power supply. So any grid losses we have assumed here, but we've not assumed, in line with the Renewable Energy Directive methodology, the CAPEX related greenhouse gas emissions. So that's actually the balance as you would do it for a Renewable Energy Directive calculation, and getting acknowledged the renewable energy share if you would use it as a fuel. So important always is to see what is the fossil reference. Here in our case of HyBalance, most obviously the fossil reference is natural gas used in a steam methane reformer and then trucked from Germany to Denmark. So that's the case the Denmark market is facing for the supply of hydrogen until HyBalance came into place. One reason, it was already mentioned, why choosing Denmark Denmark. Beside hydrogen had to be trucked in by Air Liquide into for the Danish customers, also because it's been so progressive on renewable energies. And as a boundary assumption, we've been calculating that the reduction of the hydrogen produced from wind energy is more than 95% greenhouse gas reduction if you would go for 100% dedicated renewable power to the HyBalance plant. Again, the bit of greenhouse gas emissions that you see on the left downside for the trucking is that we simply assume for the time being that the diesel that is used for the trucking of 100 kilometers of the hydrogen is still fossil diesel. So could be replaced easily moving forward with alternative powertrains and renewable or low carbon sources for the trucking as well. Now, we've made some sensitivity assessments. Denmark is very interesting because already today it has more than 70% of renewable power in the system. And that had been growing very fastly during the past years, actually. So looking from 2017, we already see that if you assumed using an annual grid mix carbon intensity factor from the Danish grid, if you assume that had been used by the HyBalance plant, then you end up to be break even already in 2017, breaking even with a fossil hydrogen trucked in from Germany. So that's actually, so you're not worse off, you're rather slightly better off if you would use grid mix in Denmark. And it's been rapidly improving over the past years in Denmark. Already 2018, we see, which is not shown here, in 2018, the grid mix factor had a value that is equivalent to if you would assume a fossil natural gas production in Denmark, so without trucking in Germany. And with 2019 shown here in the picture, you are already as low as you break even with the renewable fossil comparator from the Renewable Energy Directive, so gasoline diesel equivalents. That are the reference in the Renewable Energy Directive, you already break even there, meaning as a message, if you would use grid mix in Denmark today, at today's level of renewable shares, you're at least as good as the fossil reference. You can only be rather better than that. And there's a clear strategy within Denmark going towards 100% renewables by 2030. As there is some biogas still left in the mixtures, there will be some remaining greenhouse gas emissions there, but going towards 2030 already shows you how far the greenhouse gas balance can be reduced if you would assume grid mix in Denmark in the year 2029. So that's a great story. That's a robust development, assuming that the renewable share in the grid mix is increasing. And Lotte already mentioned how important balancing is in that respect. As there is today already more than 50% in the renewable power supply, more than 50% is wind and a tiny share of solar, so predominantly wind. And that is really a lot of fluctuating renewable power that is going into this grid. There is interesting thing that also clings into Lotte's elaborations. We made a correlation analysis actually on an example half year. How do grid prices actually correlate with a CO2 emission carbon footprints? And very nicely, Energinet DK gives a time series, a very detailed time series for past grid mix carbon footprints. And correlation analysis that we did shows that there's a very high correlation between low grid prices and that corresponding to a very high significant extent to low CO2 emissions in the grid. So in principle, you could orient your hydrogen production according to the grid price, but as a cautionary note, of course, these markets can change. Small changes in the assumptions, how the markets are built on the market price establishing rules certainly will lead to different results in these correlations. So for that reason, we did a simulation again, over a half year, first half of 2020, looking backwards on historical data and timelines, used the CO2 footprint information of the last half year in 2020 and calculated what would be if. So what we have at the moment, or in 2019, that's the latest established data that we got, is a carbon footprint of 135 grams CO2 equivalents per megajoule of electricity production in Denmark. And that, if you would produce that annual grid mix with a HyBalance plant and its specific consumptions, you end up with around about 90 grams CO2 equivalents per megajoule of hydrogen. Now, doing a simulation where you say we do operate HyBalance strictly according to demand-side management, putting a threshold of HyBalance shall operate if the grid carbon intensity is below 120 grams per CO2 equivalent of the electricity mix, then you would end up with an aggregated greenhouse gas emission equivalent for the hydrogen coming out of that operation period with 40 grams of CO2 equivalent. So simply doing demand side management with some threshold here set with 120 grams per kilowatt hour electric gives you an improvement of that magnitude. And very nicely, we've also looked into the operating equivalent operating hours from that, is that you end up with an equivalent full load period of such a plant operation with the threshold mentioned of more than 4,700 hours per year, which is very high actually. If you compare, you would use wind or wind power exclusively, you are rather in the magnitude of, depending on the site and whether it's onshore or offshore wind, rather in the range of 2,500, maybe coming up to 4,000 hours in very good sites, and with a PV plant only, rather in the 1,000 hours per year equivalents. So this is a way to how plants could be operated in the future, and I think this is very important to understand, because we are today in a discussion also about what is renewable hydrogen in the end, and what is the renewable electricity to this end that can serve renewable hydrogen. And as key takeaway messages from our analysis, so that's been part of the analysis, but I think the most important one for our discussions today, Denmark is on a very well track for renewable power deployment by 2030, getting a 100% renewable share, and that well beyond before 2050. That's a very robust development looking at the grid mix development. And power to hydrogen, Lotte also referred to that, is a key building block in that energy system integration, especially for those fluctuating parts. And demand side management of such plants is thus important. And in order to balance and to integrate in a full system perspective, of course, grid connection is important. You could do it off grid, no doubt about that. But if you want to have the additional benefits from such a flexible system, grid connection is of benefit, because then you can seek synergies and get the full system better integrated. But of course, it can't be that simple in the end before claiming renewable hydrogen had been produced. So there must be a simple but robust sustainability framework that is really needed for both ends. To the one end, towards the stakeholders like Air Liquide and Cummins Hydrogenics that have invested here with the support, public support at the moment, in order to make that feasible. But that confidence is needed for the stakeholders for further investments in the future and building the value chains for that. And of course, also to the other end, and that's the public acceptance and the public that is via taxes and etc. also supporting that at the moment. And for that, a simple but robust sustainability framework is really key on that. And there are actually a couple of policy tracks at the moment on the EU level, also on regional levels, but most importantly for the HyBalance projects, certainly the EU level. It's electricity market regulatory in general. So what is the role of electrolyzer and derivatives, hydrogen derivatives from electrolysis operations, and how is that with storage and other uses of these hydrogen used? What's their role and how are they taxed and how are they levied? There is the Renewable Energy Directive and the national implementations, but most importantly, over the next few months, that are the delegated acts really detailing or giving the details on what actually is renewable electricity that leads to green hydrogen, renewable hydrogen in the end. So that's really key for telling in the end what's the greenhouse gas balance of such a hydrogen that comes out of a powered hydrogen plant. And there's a EU sustainability taxonomy, of course, which will tell what is in the story and what's out the story of green or whatever color you want, what's in there and what's out there. So that's very important takeaways from the environmental performance side. And I hope I've been fast enough to give some room for discussions. I'm happy to look forward for that as well. Thank you.
Yes, you were very good. Thank you very much. And again, then a very interesting presentation. And I think that we are, although we are a little bit behind schedule, we will of course have time for a few of the questions from the webinar chat and all the listeners around Europe and the world that have posed questions to the presenters. Perhaps starting with you, Dennis. There's a number of questions regarding the electrolyzer. First of all, can you say a little bit more on the impact of the impact on the electrolyzer regarding the degradation, especially when taking into consideration perhaps the last two presentations and on scaling up and down production? Does that affect the long-term performance of the electrolyzer? And secondly, there's also a question that you could perhaps answer in the same session with regard to how do you see when you build larger and larger plants, do you still see it as a modular containerized approach, or how will your plants look when you go to, for instance, 100 or below, above 100 megawatt? And then, yeah, I think maybe if we start with that, then we can come back to other questions.
Okay, thank you very much for those two interesting questions. So concerning the degradation aspect, as I've tried to mention in my presentation, in fact, managing the water quality is key, in fact, in those systems, because any contamination that you would bring with the water would in fact damage slightly the stack. And so it's of critical importance. Then I assume that the question is more oriented towards the dynamic operation of the unit and the impact of the dynamic operation on the health of the stack. And in fact, at Cummins, we consider that this is a normal way to operate a PEM system. A PEM system has not been built and engineered to work in a steady operation, in continuous operation. So when we speak about degradation numbers on our technology, we consider always a dynamic operation. And from what we have seen, not only on the HyBalance project, but also on other projects that are running with our PEM technology, we consider that there is a 1% efficiency degradation every 8,000 hours. And so we assume that a typical lifetime of a PEM cell stack will be in the range of 80,000 hours. So meaning that every more or less 10 years, you could think about replacing a cell stack if you operate it continuously. If you only want to operate such a system with wind or only with solar, then it means that you are going to operate the electrolyzer much lower every year. So it means that you would in fact have a very limited degradation over a period of 20 years. Concerning the, let's say, way forward and looking into 100 megawatt plus projects, obviously from our perspective, our biggest priority today is to deliver on the 20 megawatt project which we have today with Air Liquide in Bécancour. And this will become our reference plant, as the HyBalance project has been a reference plant for all the new customers that we have had since. The Bécancour unit will be our reference plant. And so we expect to deliver some projects in the same scale in the coming years. The 100 megawatts plus type of units, obviously the first one, they will get inspiration from what is being done at Bécancour. But if we are looking at gigawatt plants, we need to make an additional iteration on the technology. And obviously the motto at Cummins is what is bigger is cheaper. Every time we make a component bigger, let's take an example, the stack, the costs are not doubling when we double the size of a stack. So there is clearly a strategy to go to bigger stacks, also to have more stacks sharing the same balance of stack. And especially on those very large plants, there are a lot of, let's say, cost benefits when on the utility side. So centralized cooling, etc. And that's something that we see already, that on the small units, all the utilities are included, but on the big ones, we are dealing only with EPCs and will not provide reverse osmosis system, medium voltage equipment. No, this will be provided by additional equipment supplier in this project. And this will allow for a true cost reduction of the large scale project. And our aim is really to reduce the cost of the central electrolyzer piece, which is for us, the stack and the balance of stack. I hope I answered the two questions.
Well, I think you did. I don't know about the people who originally posted the questions. I mean, in the chat, but at least in my perspective, it was a very thorough and good answer. Just a practical remark before we proceed to. There's been several questions regarding the presentation and the accessibility of the webinar afterwards. Everything will be available at hybalance.eu in a few days, so there you will be able to see also recording of the webinar as far as I'm aware. Anyway, moving on, there are a few questions in the chat also, which I think is for Air Liquide. So perhaps, and apologize again for my pronunciation, but Diederik, if you could answer both regarding the byproducts, one which is the oxygen. It's a question that I think is often posed in regard to hydrogen projects. Did you use the hydrogen in this project, or do you have any in any similar projects? Is there a business case to be made from the oxygen oxygen production, obviously, the oxygen production, and secondly, what about the surplus heat that's generated, again, both perhaps in with regard to HyBalance and more generally, is that something you see as an additional value stream in electrolyzers also when we're scaling up?
Thank you for the question. So in fact, yes, this is very important. We always look for the optimization. So every oxygen molecule that we get out of the unit, of course, and don't use is a loss of income, loss of energy. So we try to optimize those streams. In new projects, we're also looking into that very seriously to find the right basin, in fact, to install electrolyzers. Where we can have either residual, let's say, heat into heat networks for heating towns and so on. So we do that, and we try to find spots also where we can recuperate and use the oxygen into industrial processes. So it's a very good question. In fact, it helps us to optimize. Now it depends a bit on of course, of the value that we can extract from the oxygen and the heat, but my experience is so far that if we even around our own network, we inject some oxygen potentially into our own oxygen pipelines, yes, we can make business cases, and the more we scale up, the better it will become, for sure. So the best is to use everything that comes out of the electrolyzer. We are committed to do that as much as possible.
Well, thank you for that answer. I think that I know that there is, to our listeners that there are a number of other questions in the chat, and I do apologize for not being able to take more of them, bring more of them to our distinguished speakers. But unfortunately, time is also of important here, and we need to unfortunately move on to our next session 2, and we're already a little bit behind schedule actually. So I would like to thank all the speakers in our in session 1, and then move on to the panel discussion here in the second part of our seminar, and we are once again lucky to have very good participants for the session. So I'd like to welcome Daniel Frail from Wind Europe, and also Georgios Pavlik. I'm sorry again for my perhaps not completely correct pronunciation of both your names, from Hydrogen Europe, the European, respectively the European Wind and Hydrogen Organization, as should be implied by the names, who are here to talk a little bit about how do they see the market development and the need for EU regulatory frameworks, with regard, of course, to projects such as HyBalance, and including the possible certification of the hydrogen as well as the energy that goes into the electrolyzer when we move forward. So I think if we start by some short initial remarks by you both, and then we will move on to a more discussion, and also the chance for include both speakers, other speakers, and questions from the audience. So Daniel, if you would make some introductory remarks on the subject, then that'd be excellent. Thank you.
Okay, thanks a lot. Thanks a lot for the invitation. And so far, very interesting conference or webinar. So as you already mentioned, I'm representing Wind Europe, which is the association covering the wind energy industry. We have 450 members, and we're based in Brussels. So, I mean, coming to the topic, we are obviously very interested on the decarbonization of the energy system. We've been calling for that for a long time, and the way we see it is we need to decarbonize mostly through electrification. And I think that's where hydrogen becomes a very important part. We think that we need to mostly use renewable hydrogen, of course, and that will help a lot in decarbonizing those hard-to-abate sectors. Otherwise, we think that we can also work on electrifying first. So that's more or less our vision. Coming on the more concrete questions that are on the agenda and about the regulatory framework, I think this is quite a hot topic today. We have the strategy from the Commission, but we have a number of other issues being discussed at the moment, like the Renewable Energy Directive, for instance. And I think the question is mostly about whether we need a specific regulation for hydrogen. And I think that the answer is, well, we need definitely a specific definition for hydrogen that could enable promoting that specific types of hydrogen. Yeah. So we need to be much more clear on what is renewable hydrogen, what is green hydrogen, what you want to call it. And this has been this comes very evident in the discussions we are having now on the Renewable Energy Directive, the implementation for the transport sector and the fuel supplier obligations, where the Commission has made an attempt to define renewable hydrogen, but clearly it's not yet done, and this opens a lot of conversation, which are very interesting. And so it shows also the complexity of the issue. But I think we need to continue working on that. That's extremely relevant. I think also it has, if you look at projects like HyLaw, that they have been doing a very good mapping of the regulation across Europe, you can see that most of the barriers that you find is the lack of a specific regulation for hydrogen or for power to gas, let's say. And so that clearly makes it very difficult. We saw it from the previous speaker from Centrica, from Lotte. She was talking about the value of providing grid services, and there are a lot of possibilities. But again, here sometimes it's very difficult. It happens the same for renewable energy. You can get a lot of value from those markets, but actually you need to first be able to compete on those markets. It needs to be open for you, and it's not the case for example, for electrolyzers in all countries. Load cannot always participate on those markets. And once even if you can qualifying for those sometimes it's very complex. The pre-qualification criteria is very, very difficult and maybe not well defined in a technology neutral way. And it's different across countries. So that makes it always very, very complex to make a business case for electrolyzers in this case, but sometimes even for a wind farm where you also want to provide ancillary services. So I think that's maybe one of my messages, that we need to clearly define, in this case, renewable hydrogen, and how do we want to support it afterwards. I'm gonna leave it for the moment. Okay?
Well, thank you very much. I think that was a very interesting perspective. And turning to you, Gregors, what is regulation really what is? I mean, there's all this sort of momentum and buzz around hydrogen in Europe at the moment. Is the regulation and the regulatory framework able to keep up in your perspective, or do we need to see new rules and regulations in order to steer the hydrogen market in the right direction?
Yes, good morning. Thank you for this question, and thank you for having me. And I apologize for not being able to use the camera. I have some internet issues. But coming back to this question, well, I think it has to. We have to have new regulation. The current ones are certainly, as has been mentioned, with the HyLo project has clearly shown that the current regulations are not keeping up with the changing of the landscape. And if we are serious about reaching the targets set out in the EU hydrogen strategy, we certainly need to have regulations that would allow those targets to be reached, because currently there are just too many regulatory gaps and market gaps that are there that make it very hard to do by the project developers, even so ambitious as the ones that have presented the project today. And I would just want to go back to one of the points about the certification, and that's one of the clearly missing bits of regulation that we are all waiting for, and we hope to make that happen as soon as possible. And this is not only something that's needed for the purely renewable hydrogen that is clearly produced from renewable sources, but also for a project like HyBalance, which was mentioned also in one of the previous presentations, that when you produce, depending on the time of the hydrogen production, whether you produce it in low prices, whether you use produce it in time when there is high renewable energy penetration, the carbon content changes, and you can even use grid electricity to produce purely renewable hydrogen. But the fact remains that it's only you that knows that it's renewable, and it's not completely recognized on the market. And this also should change, and we hope it will change in the future, because it's certainly needed. And also about when it comes to the certification, one thing I would also like to touch upon is that hydrogen clearly needs also its own certificates. We know there is discussion going on at this moment about how the green certificates of origin for hydrogen should look like, and there is a lot of maybe not a lot of, but there is a certain push for hydrogen guarantees of origin being a subset of the natural gas or the hydrocarbons certificates of origin. So biomethane, hydrogen, all being in a single scheme, and we feel that is not the way forward, because hydrogen has a special and really separate role to play on the energy market in the future.
Yeah, well, thank you. And do you, I mean, you say hydrogen has an interesting role to play, or an independent role to play in the energy system. Do you see hydrogen's role mainly as an, I don't know how to phrase it, but maybe as an instrument to sort of assist the energy market, or do you see hydrogen as something where the hydrogen production will be an aim on its own, and the electricity market will have to substitute the production of hydrogen? So I don't know if the question makes sense, but whether hydrogen is more a flexibility provider or actually a production of its own.
Well, we certainly feel that it's one of its uses, and it's certainly important one, and it will certainly be necessary for hydrogen to play this role in a fully decarbonized power sector. But this is certainly not the only, and it's not even the most important use of hydrogen. Well, if you want to decarbonize the heavy industry, steel production, ammonia production, the heavy duty transport like trucks, maritime sector, well, we clearly can't do it without hydrogen. And if you accept this fact, then it clearly becomes more beneficial to produce hydrogen as a primary product in a full load, in a electrolyzer plants working at full load, and not only using excess renewable electricity because then the capacity factor of your electrolyzer is so low that the cost of hydrogen becomes also high. So we clearly see this is a huge part of what the role hydrogen has to play in the future. This grid balancing services and providing seasonal storage and all that. But clearly the role for hydrogen is much bigger than that.
Thank you. And Daniel, perhaps your perspective on the same question. I mean, you represent one of the perhaps one of the two major renewable power producing technologies that we will see sort of be leading the green transition in Europe, and thereby also fueling electrolyzers. And how is it mainly a flexibility tool that you can use, or do you see in the expansion of perhaps especially offshore wind production as dedicated to hydrogen production?
Yeah, I think it's a very good point. I mean, obviously, hydrogen needs to be by itself valuable, right? I mean, you need it for decarbonizing some of the industrial sector, as it was mentioned. So it's not a byproduct of the energy market, if you wish. Yeah. But now, if we are going to have a lot of production of hydrogen in the future, and it's flexible on the demand, I think we should build on that, because it would be a lost opportunity if you now start building huge hydrogen production facilities which have very little flexibility. I mean, we are now pushing on all industrial sectors to be flexible to do demand response. How could now a new player come which has a possibility and will not implement that? It might be very good from an economic point of view in some cases, but I think we are going to be missing out a very important element if you then go to systems with a very high share of renewable energy. You know, Denmark has a lot of wind, but it's also a very small country, very well interconnected. It has connection to the Norwegian hydro, for instance, and to the German grid and so on. So they can balance the system at very low cost. But if you go to countries like Iberian Peninsula or Ireland and so on, when you have high shares of renewables, then it will have a very strong cost on balancing the system if all the demand is not flexible. So I think we need to build on that. And I think the electrolyzers have this potential. Whether this is the most cost-effective solution for balancing the grid, well, I mean, that will need to be put into competition with there are many other possibilities. I think we should be working on all of them. But there is also the story, if you want to claim that this hydrogen is low carbon and it's renewable and so on, we also need to build it in the story of a system which is dominated by variable renewables, and then it needs to become flexible. So I think this is the story today. This is where the complexity comes, finding the balance. Yeah, finding the balance to make it a bit more competitive, and at the same time having something which can really help the integration of renewables going forward. It might not be necessary in a country with a 10% share of wind and solar, but definitely it will be important in a country like Ireland, which already manage 40% wind in an electrically isolated system.
Yes, which without having any prior knowledge to the Irish electricity market, I would imagine with a huge offshore wind potential being placed in the Atlantic. But I think it's perhaps then going back to our other our speakers and to Ellie Keat. So Diedrich, what do you? I mean. Building, of course, on your experiences from the HyBalance project, but also as one of the major industrial players in the hydrogen markets and such. How do you see the European hydrogen market develop? And what perhaps can you also, I mean, it's been very clearly stated from the Commission that it wants Europe to take a leadership role here. What do you see as perhaps the main obstacles for and the main steps that Europe needs to take in order to fulfill that ambition? That is clearly also what's fueling projects like HyBalance, etc. But we'll of course need to develop much further if we are to reach the very ambitious targets for electrolyzer capacity, for instance, already in 2024 as set out by Mr. Timmermans.
Yes, thank you very much for the question. So let's say to answer your first question, how do you see the market evolution? What is very clear to us is that the market is absolutely needing scale up. So there's we're focusing, and myself and my team are focusing a lot today on the energy market. So we focus not on the entire market, where there's also the as-built industry, the power trades market, and so on. This is let's say the renewable fuels. This is not what me and my team are focusing on. We are very focused today on the mobility market or energy market, using either it through fuel cell or combustion engines. If we look into that, you know, what's very important is that, you know, infrastructure. I think we can progressively. We have a lot of lessons learned. The HyBalance project is helping us a lot in getting more mature into this market, having new insights, scaling that up. So in that respect, we're very thankful to have been playing a big role in this project. The next step is creating also demand, and this is where I see is what is typically or need to be done is that we get the chicken and egg problem together, which is getting the supply on one side, but also find the market to economically, you know, sell the product that we generate with renewables. And this is that's the main focus today. So we have some big projects. One of them is that we went out for in the press is what we call the HyTrucks project. We have major logistic ports in Europe that would like to foresee, let's say, with a number of trucks, ships, and so on coming in. You know, having also the experiment and create, you know, with new innovation, also the demand side. So this is how we see it moving. We also believe a lot in good infrastructures like networks, because what we don't want to do is to transport too much of the product on the roads. That's nice, but it is not probably the future. So this is what how I look into the market. So we would like to partner up, and we need to have partners in realizing all this in bigger scale-ups. In terms of obstacles, there are quite some probably regulatory obstacles in the sense of steps into the unknown. You know, we see authorities not always that well known with the product. Yeah, so this is where there's also training to be done, general acceptance of the market, that we master the technology, that we can bring safe technology into the market. Then there's the, let's say, all the regulatory obstacles, which is how to deal with, in this case, mobility markets. You know, can we park vehicles into parking garage and so on? It's very, you know, there's a very wide set of interpretations on all these kind of things, which is making the use cases somewhat more difficult in their acceptance. But there's also about crossing tunnels, or parking, let's say, outside on bigger parking places. So also let's say on the use case, I'm focusing more on the mobility market, but where can we store hydrogen and on trucks? You know, can we do we get on tractors or on vehicles additional space by the authorities, you know, to make it very competitive or to play with the dimensions of the vehicles? Such kind of regulation needs to be prepared and it needs to be well done. The first ships that we have or that we are preparing to get propelled on the rivers with hydrogen. There's also a lot of you know, regulation on storage on board of ships. As soon as we come with exchangeable assets on a ship to bring hydrogen effectively on board, you know, the part that we bring on board becomes part of the ship. You know, as soon as you connect it, it's a fuel tank. So it's there's no regulation around all this. So it's things that we need to prepare. Things where we are very constructive, let's say, discussions with authorities and notified bodies, but it's a way to go. And that's where I think when we get that all flattened out and we get up to more consensus between all parties, then it will lift off. But it takes some time. So in terms of obstacles, this is what we face in reality, and where we focus on today with good lobby and help also of the authorities to get a better playing field.
Well, thank you very much. That was a very, I think, a very good and thorough answer. We're in the chat. We are having a few questions regarding the issue of what kind of hydrogen will then fulfill the demand, at least in the beginning. Will it be blue hydrogen? I mean, hydrogen with CCS involved in the production, or will it be hydrogen from green and renewable sources such as HyBalance? And I guess one of the questions here is also whether both renewables as well as electrolyzers can scale up. So perhaps the threefold question here: one to Dennis and Daniel, whether can electrolyzers and renewables sort of move fast enough to meet hydrogen demand, and then perhaps one to Gregos, and how, as representative of the wider hydrogen industry, you see the supply of hydrogen during the next few years, and also with the very big ambition set in Europe. Can we meet the demand with green hydrogen, and what does it take? So Dennis, you first, then Daniel, and then Gregos. Thank you.
Yes, very interesting question. I would say that Cummins, as all the electrolyzer players, recognize the huge pressure I'd say the policymakers is putting on us actually to deliver the right technology at the right scale at the right time. And so I cannot disclose any news here today, but everyone is working on expansion plans.
Come on, we were looking for some news.
No, but I mean, all our competitors and us are working on this. There is also large funding opportunities being organized, especially at European level, to actually capture the manufacturing of electrolyzers in Europe. But at the end of the day, we should not forget that this is a global story. Obviously, the topic here today is mainly in Europe, but other regions are moving as well on those topics, and they need to be considered. So clearly, we will be increasing our electrolyzer capacity significantly in the different regions of the world, close to where the markets will be. And so we have a strategy for Europe, we have a strategy for China, and the rest of the world. But the aim is really to deliver gigawatts in the next 3-4 years, for sure.
Thank you. And Daniel, can you install the capacity needed to power all the electrolyzers that Europe and I guess also the wider world aim for?
I'm not sure how many electrolyzers the world need, but what concerns us, I think clearly we are scaling up also the production of electricity, renewable electricity in Europe. We're trying to already meet our, let's say, the goals set by the National Energy and Climate Plans by 2030, which are already quite an ambitious goal by itself. But clearly, as we see the market today for hydrogen for electrolyzers, we can easily match up the capacities, and we're ready to upscale. But you may have seen the goals that we have also coming from the Commission's decarbonization roadmap to 2050, and most recently with the impact assessment to reach the 55% reductions of greenhouse gases in 2030. I mean, let's say the bar is it's very high, so we need to really do a lot more than we are doing today to be able to have those capacities. For us today, the major issue for wind is still permitting to build all the wind farms, but I think the business case there it's clear, is there. And we are very much looking forward to do partnerships with the hydrogen production facilities in order to achieve that. On your questions about I still wanted to comment because you say, is it a renewable-based hydrogen or blue hydrogen for the transition and so on? Well, I guess we should stay technology neutral. I guess if we want to achieve CO2 reductions, both are feasible. Question here, because we hear a lot about the blue as a transition, but we don't see many projects on blue hydrogen out there yet. So I'm not sure what transition it is. I mean, I guess both technologies are developing at the moment. So I think we should give room for both. Yeah, I just wanted to say that. Mm-hmm. Thank you.
Well, yes, thank you very much. And Gregors, your perspective on this matter, perhaps as a more industry-wide approach.
Yes, thank you. That's indeed a very good question. When we look at the pipeline of renewable hydrogen projects that has been announced today, so projects that were being developed or started being developed even before the hydrogen strategy has been announced, what we see is around 2 gigawatts by 2030, so 1/3 of the EU target, and around 12, 13 gigawatts by 2040. So well below what the EU target is for those timelines. But since those were developed in a place where there were no hydrogen strategy, the regulations were the gaps, the regulatory gaps are there. So we clearly feel that there is certainly room for the market to fill that gap in time for the targets to be reached with 100% renewable hydrogen, as the hydrogen strategy says. But having said that, even if we meet those targets and we produce those 10 million tons of hydrogen by 2030, this is just a drop in the sea of what the needs are in order to decarbonize, as I mentioned, the heavy industry. I mean, the maritime sector itself would need tens of gigawatts of electrolysis in order to produce the renewable fuel that we would need, whether it would be hydrogen or ammonia, or methanol or whatever. It all would need renewable hydrogen as a feedstock to produce those renewable fuels. Then we clearly see that blue hydrogen also has a role to play. Either as a transitional fuel or transitional option before we ramp up the capacity to produce green hydrogen in the amounts that are necessary. But we clearly feel that it has its role to play at least until 2050. And I would kindly disagree that there are no projects. I mean, we have a guest from Air Liquide, and they are currently already operating a blue hydrogen production plant in Port Jérôme, I guess, in France. And there are also many other in the pipeline. And the difference is that there are not as many of those projects, but they are usually bigger in scale when you look at a single blue hydrogen production plant that can produce 50,000 cubic meters of hydrogen per hour. That it's a different scale to what we have today when it comes to green hydrogen. So just to cut it short, yes, the answer I give is that in the foreseeable future, if you want to reach the decarbonization targets that we have in place, I don't think how we can do it without blue hydrogen, to be honest.
Yeah, well, thank you, and Dietrich, you wanted to weigh in on this issue as well.
Yeah, just a few words probably, and Gregors has mentioned it already well. I think we, when we look into the entire production capacity of electrolyzers worldwide compared to the installed base already of what we produce, in terms of hydrogen, there's a very large gap. So we are very convinced that, and I think also many policymakers with us, that one of the big steps that we can take as an industry is to decarbonize first the installed asset base already of existing steam reformers and other production methods, to make sure that we capture from a worldwide perspective as much as possible CO2 already. So we are very active in carbon capturing, doing that not only for our own steam reformers, but also for the industry in general in large port areas, which is first a big step. And then the scale-ups, you know, the way we see it moving is that certain industries, you know, that are very visible, like the automotive industry or shipping industry and so on, everything that we would like to do in addition, in terms of additionality, we would like to be as green as possible. But there's for sure there's a big place in this energy transition period for low carbon hydrogen, which is and just to give you you know some little figures or imagination, that in a port like Rotterdam, in the installed base already of hydrogen production, that where we can capture it's around last year's figures of the aggregated production capacity of electrolyzers, 80 times the annual production of all the electrolyzer producers together. So in order, if we would like to go fast in this world with decarbonization, this is one of the measures and one of the things that is already good. And even I would like to take away also probably the taboo around gray hydrogen. Even gray hydrogen, as it is produced today, is much cleaner than already the same combustible in an engine, in an internal combustion engine. So if we use it, if we produce it in the gray way as today with a steam methane reformer, and use that in a fuel cell technology, the outcome is better because the process is much more efficient. And also there's let's say the methane slip or other things that we probably don't discuss here have an impact on our environment. So there's a big play for blue hydrogen, or low carbon hydrogen as we call it today, in the world, and we need to go. We can go fast there and start up or kickstart, let's say, hydrogen economies based already on the installed base, because it's about creating demand that goes together with production. That's what we think is the future to lift off the hydrogen economy.
Okay, thank you very much. A very also interesting perspective and an interesting discussion that I think we will definitely see also progress in all over Europe in these days, weeks, and months ahead of us as the implementation of the hydrogen strategy moves further. And I think at least what at least to me and judging from the excellent presentations that we heard during this morning, to me it's clear that also that what HyBalance has helped show is that there is definitely also a huge potential for hydrogen production, but also for, as Lotte mentioned, interacting with the electricity grid and with the renewable resources that Daniel represent. And I think there is really a number of issues play. I think very interesting perspectives and many areas where hydrogen will fill a role. That has been a pleasure for me to moderate the discussion here today. And also I had the honor of being present at both the groundbreaking and the inauguration of the HyBalance plant. And I think it's not that long ago, and if you see what the debate on hydrogen was when there was the groundbreaking ceremony for the HyBalance plant, and it is today, it's just something about how fast this debate has also moved and how fast hydrogen has developed from a relatively small to a area in European energy policy to being absolutely vital for the green transition in Europe. Regardless of what kind of hydrogen that we're looking at. So I think that's something that we could continue to discuss for a very long time. And I think the perspectives are huge and impressive along the value chain that has been illustrated by HyBalance, and it's been my pleasure, as I said, to hopefully facilitate that in an understandable way today. I would also like to thank our many viewers around Europe for tuning in, and as I mentioned, the HyBalance Consortium informs me that there will be a recorded link also available on the HyBalance website within a short period of time after the seminar ends today. So, but to sort of sum up, I would like to give the floor to. I'd like to thank all our panelists and for their contributions, and then give the floor to Nikas. Yeah, again on a little bit struggling with the presentation pronunciation of your last name, but
right, it's
Limpopoulos.
Limperopoulos. That was very close.
Okay, well, a lucky punch, I think, but nonetheless, from the fuel cell and hydrogen joint undertaking to sort of to take in the, let's just to sort of summarize our discussions here today and to finish the seminar. So please, you have the floor.
Excellent, thank you. Yeah, I thought that was a very interesting exchange of information today. My name is Nikos Limperopoulos, very long and very Greek name. And I am the project officer at the FCH-JU, who had the privilege of following the HyBalance project for the last 6+ years. It's a project of a duration of 6 years, but the project effort started earlier in setting up the call topic, in evaluating proposals. HyBalance was the successful one. And then a long negotiation period has started. And I think the consortium would appreciate our firm but flexible stance of the FCH-JU colleagues in signing the contract and eventually realizing the project. 6 years, a lot of things happened. We had 3 different project coordinators. I can mention Charline Dubois, Jessie Pons, and Guillaume Jarin. And always with the support of Louis Santis from Air Liquide. We saw partners changing names, but still the core was always there and managed to successfully complete this project. So very briefly to summarize what we heard today, hydrogenics. I think hydrogenics realized the real challenges when moving from the lab to the real world industrial sort of environments. They had challenges in terms of securing safe, reliable, and even quiet operation, as you saw by the huge low noise cooling fans, in getting licensing, etc. We heard that dynamic operation didn't affect the degradation of their units. 1% efficiency degradation per 8,000 hours, that's great, meaning 20 years before you change your stack if you operate it on renewables. Air Liquide, they faced a lot of challenges in setting up the final consortium, signing the grant agreement, and then having all these engineering, licensing, organizational arrangements in running and maintaining the facility, in having commercial agreements for selling the hydrogen, all very real world challenges, and I think a good experience. So they have successfully used the facility to produce 120 tons of hydrogen since 2018. And they're looking opportunities to use even the oxygen and the waste heat. From Lotte, very interesting to hear about the electricity market opportunities, that electrolyzers can submit bids previous day or intraday in power frequency regulation with the potential of a lot of earnings. And I look forward to receive and go through the reports of the project and see some more specific figures on those earnings. And LBST, very interesting results as well, to see that there is a 95% reduction potential for the hydrogen that is currently being sold in Denmark, if this facility is to use renewable electricity. But even if we use the Danish electricity mix today and go to 4,700 hours where the CO2 emissions are low, we can go down to 40 grams of CO2 equivalent. Very impressive. And then the panel discussion I thought was also very interesting. Wind Europe, always great to collaborate with Wind Europe. They recognize hydrogen as a means for renewable energy, wind energy, to decarbonize hard to direct electrify and decarbonize industrial sectors, heavy duty transport, etc. Regulatory framework is a hot topic, Renewable Energies Directive. We need specific definitions on renewable, green, low carbon hydrogen. And hydrogen will have its own market. It's not a byproduct of the electricity market. That's very interesting to state clearly. Gregors from Hydrogen Europe again stressed the need to have the right regulations, certifications, the missing links of regulation again there. We hope to have this being realized soon, and certificates and guarantees of origin for renewable or low carbon hydrogen. That would also allow, I might add, cross-border trade for hydrogen. That is going to be quite important in the future. Interesting to hear from Air Liquide the fact that authorities need also to be trained with hydrogen technologies. Indeed, this is the case. The FCH is also trying to address this as well. There was the question on whether renewables and electrolyzers can grow fast enough. Indeed, it's a global story, as mentioned by Hydrogenics/Cummins. Our understanding is that electrolyzer OEMs in Europe are currently scaling up their production to be able to produce roughly a gigawatt of electrolyzers per year in Europe. We heard that not many blue hydrogen projects around, but the few that exist are very large scale. Impressive to hear about the Rotterdam facility that would need 80 times the global electrolyzer manufacturing capacity to replace that one facility in the port of Rotterdam. Right, and to wrap up, yeah, it's been a great adventure, this. I will try now, if I can, to share one slide with you. Hopefully you can see this favorite slide of mine on the FCH-JU support to electrolyzers. On the left, it's the millions of euro, 38 projects, different types of electrolyzers. And on the right, it's a little schematic of all our electrolyzer demo projects. Now, 2011 is the Don Quixote project, few hundreds of kilowatts, 150 kilowatt electrolyzers, again by Hydrogenics. And then we come to 2014, our first real pilot project for electrolyzers, HyBalance. This is a 1 megawatt, 1.25 megawatt electrolyzer. And the blue bars, if you follow the blue bars, they refer to the axis on the left, is the electrolyzer capacity of our largest electrolyzer demonstration projects. Also of interest is the red dots, which is the right axis, the FCH-JU support in million of euro per megawatt of electrolyzer installed. You can see HyBalance here. And then 2 years later, we had H2Future, the only other project with an up and running electrolyzer, a 6 megawatt atmospheric PEM in a steel plant. Demo for Grid is the next one to come online. It's a 3 megawatt alkaline in a food industry. Then the next year we had Refine, a 10 megawatt pressurized PEM in a refinery, and Aeolus, mentioned previously, which is going to be installed inside a wind park. 2018, it's our biggest 20 megawatt alkaline, pressurized alkaline electrolyzer project called Joules. And Mirella Tanasiu mentioned that there is a 2020 Green Deal call out now by DG Ener for a 100 megawatt electrolyzer that has half the support per megawatt that we provide for Joules. So you can see the effect of economies of scale on one hand and improvements in the technology and the CapEx. But still, all this very impressive, but HyBalance has set the scene and provided all the right experience and expertise to this industry to be able to make this leap and allow hydrogen to indeed become a major player in the energy and environmental policy of the EU. And with this, I would like to thank everyone, the project partners, for sure. I look forward to a successful wrapping up of the project. Thank you to all participants and all speakers, and hope to see you one day physically soon in the near future. Over and out.
Yeah, thank you, Nikos, and thank you everybody over and out from here as well. Thank you, it was a pleasure.
Bye.